Hi, my name is Lars. I work for the Mozilla Corporation, and I am Mozilla's only certified fashion model. I have actually been in Maxim Fashion magazine back in 2001. I'm here to talk to you today about a piece of software, a Python library called Configman. It's likely a library that you will never use. But it contains some very interesting ideas. And I want to impart those ideas to people to give them incentive to create other things. So a little bit about myself. I'm going to have to explain some things about myself before you can really understand what this library really is. So I am what I call the herd patriarch of the web engineering department at Mozilla. And I know no members of the Duck Dynasty cast, so don't ask me for introductions. Standing before you right now is a man with a very unusual mind. I have an interesting synesthesia. I see code and complicated curves in colors. I did not know that this isn't the way everyone else's brain worked until about 3 years ago. And then I started talking with people about how their brains work. And I discovered that I am very, very different. When I was a child, about the first moment I picked up a pen, I started drawing curved lines. Why did I draw curved lines? Because they were very interesting and they were colorful. This is clearly a black and white drawing. I can see that it is black and white. But I can also see that right through there is a stripe of blue. It's not that it's actually looking blue in my eyes. It is the concept of blueness. This is a drawing that I did in approximately 1980. I was 20 years old. And I was just sitting there for hours on a piece of rolling shelf paper. It ended up being 2.5 feet wide, 6 feet long, with a density of approximately 2 millimeters between every line. So I went to college. Actually, next month is the 40-year anniversary of the first programs that I wrote. They were in BASIC. And prior to that, I was playing around with hardware, TTL logic, things like that. My father gave me a 1955 Tropicana pinball machine, electromechanical logic, and I tore that thing apart and taught myself Boolean algebra with relays. Then when I went to college, ended up in graduate school, I took a course in artificial intelligence where I learned the language Lisp, and I had an epiphany when it came to recursive pattern matching algorithms. Suddenly, I suddenly understood this, all of a sudden, the colors became amazingly bright. I was in a course, or in my artificial intelligence class, I was probably doodling, drawing things like this, and not listening to what the professor was saying. He put up an algorithm on the screen. At that time, overhead projector, handwritten. And I suddenly looked up because there was a flash of blue on the screen. And he clearly was using a black pen. And I had to raise my hand and said, "Professor, there's something wrong with your algorithm here." Now, I couldn't tell him what the problem was. I didn't know. But it was blue. And ever since that point, if I look at a piece of code, if it has a bluish cast to it, I know there's a problem in that code somewhere. Something in my brain does not understand it. Good code is greenish, yellowish, orangish. This drawing has red in it. Code is never red in my head. But blue and purplish colors means there's a problem. Keep this in mind. This is the aphorism that I live by. There is no problem that cannot be solved with another layer of indirection. And you are going to see that Configman is nothing but layers of indirection. So let's start. what is configuration? If you look up configuration in Wikipedia, you find it is a data resource for program initialization. Simple enough. So, how do you get config into a program? What do you do when you write a program and you want to get configuration information in? Program reads it. From where? How? Text files. Are there other ways? You could have command line arguments. And here are some Python methods of getting command line arguments. There's another new one called click recently that I found. It's very interesting, done all with decorators. Config files, like you said, there can be INI files, JSON files, all sorts of different ways. Python gives you the option of several different ways of reading just simple INI files. JSON files, I know at least 3 JSON libraries. Python modules, Django, you have a local.py, and that's how you get configuration to your Django app. And other applications use Python modules just to, as the configuration language. There are too many to enumerate. XML, sorry to use a 3-letter, 4-letter word, but and YAML. Just your operating environment, os.environ, is a way of getting configuration into your program. But you know, they all boil down to essentially the same thing. They are key value stores. So wouldn't it be nice if they all had a compatible API? They all worked exactly the same way so you could interchange them? Perhaps let's just go way off the deep end and say perhaps they could be collections.mapping? Seems rather simple. All right, hold that concept in your mind. Configuration is just mappings. We're going to digress here. We're going to digress all the way back to childhood and start playing with Legos. Here we have 5 Legos in a row. Actually, I guess the plural of Legos is Lego also, so I apologize for the purists here. If you were to look at this pile, or this line of Legos, from straight down, what colors would you see? Well, 5 white Legos. That's pretty simple. Let's add a couple more. Some blue ones. Look straight down. What do you see? Blue, white, blue, blue, white. Add a couple more. And looking straight down, green, white, blue, green, green. A couple more. Add some yellow. By the way, you are going to see colors of Legos in this thing that you had no idea they made them in that color. I went to the Lego website and ordered 10 of every color. So, green, white, yellow, yellow, green. Add a couple orange ones. And we have green, white, yellow, orange, orange. Let's put some labels on these Legos. What does this actually mean? Now, some of these labels that I'm going to say here may not make any sense right this moment, but they will in a little bit. Let's call white ones defaults. And we're going to call blue ones application defaults. Configuration file is green. Environment is yellow. And command line is red. Or I'm sorry, orange. So each column represents a configuration parameter. If you know Postgres, this is obviously a Postgres. Host, port, DB name, user, and password. The defaults, localhost, port, the default Postgres port. DB name, this particular library that implemented this Lego thing here, has the white things as defaults. Then when you wrote your application using this library, you put in application defaults. You changed the host to be localhost, the DB name, and the user. And then when the person used your application, they made an INI file, and they put in the green things in their INI file. The IT person who was running this program on behalf of the user put in the environment the yellow things. And then finally, when someone else executed the program, they on the command line changed the user and password. What do you get if you look straight down on the top of this? What is the configuration for this program? This IP address, this port, our database, Selena, and an actual password. Welcome to the world of Configman. Let's talk some basic use here. We have here what is essentially a 3-line program. Pep8 makes it into a longer program. Let's look at this defaults. It's just a dictionary. Key value store. Host name, localhost port, DB name, user, password. Set those. This is the white section of those Legos. Now we'll look at the next 2 lines. We're just going to, from the Configman module, we're going to import a function called configuration. We're going to run that, invoke that function, passing in the defaults. And then out of it, we're going to get this config object. Let's just stop this right here, go to the command line, and run this thing. So we're going to say Python o1.py and give the help thing to o1.py. The O stands for both ends of Ohio. Just running help on that 3-line program gave this help output. What we see here is some administrative things that Configman set up, and then your configuration variables that you set, host names. Now these doc strings are pretty useless, but we made a pretty minimal program to begin with. We can correct that a little bit later. So let's run this program again. Set some environment variables, host set to 2 braids, user equals Ethel. Python, we'll run it. We're going to set on the command line, we're going to say the DB name is Fred, and the user is Wilma. Sets up this system. We have our defaults. We're going to override the local host with that. Well, you can see, look down from the top. You can see what the configuration will be. We're going to add one more switch to this called admin dump conf. And that says o1.ini at the end. Sorry, it's cut off on the screen. What I'm telling Configman to do is go in, create this situation, go in, get all of these configuration variables, and then dump them into an ini file. So if I cat that ini file, I see those values that I've just set. So automatically, right here, we have the ability to make our application write their own ini files that we can then go in and edit and to however we want. But Configman understands anything that is a key value store. JSON files are key value store. So in this one, I'm going to call this print conf. It's different from dump conf. Dump conf writes a file. Print conf just sends to standard out. And I'm going to say, write it as JSON. And then I'm going to pipe that. There's a pipe to pretty print. Here's that output in JSON. I could say .py, and it would write a Python module for you with those values. You could say as argparse, and it will write the whole setup of argparse for you, so you can throw out configman and just use argparse because you prefer argparse over anything else, or whatever you'd like. So now, run the program again. This time we're going to bring in that configuration file, and you can see we've just paved over our defaults with what was in the configuration file. Add some more things to the command line, which will override yet again. You get the idea of what we're doing here. So anything that is a mapping can be used as a source of configuration definitions or configuration requirements. These are called definition sources. Anything that is a mapping can be used as an overlay value. These are the ones that I call value overlay sources. This is your OS environment, your command lines, all of that stuff. So you can, in this particular case, this is the little segment that we used earlier, we can override some things. Let's move that defaults into a keyword argument, and then make a value source list. This is what the default is, some config file that we're going to get in the future, the OS environment, and whatever command line source we decide we want to use at that point. So there's something missing here. If we look at that, note the colors. The white, the defaults. Now they're inverted from the Legos. I couldn't hold my Legos upside down. But we have our green configuration file, our This is the hierarchy. This is the lowest level, on top, of course. And the blue is missing. This is our opportunity to put in application defaults. So we brought in a library that took in our original defaults, and then we made some application overrides, and then we let the IT people or the users override in whatever method they want. If you decide you don't want command line parameters at all, just leave out the command line thing. Or you don't want to use environment, just leave that out. You can have any key value source in there that you want, and I mean anything. If it follows the collections.mapping API, it can go in this list. So, imported modules. I thought there was something more fun here. Well, you can put modules in that list. It'll read all the items in from the module and overlay those things in. All right, it's time for our first level of indirection. And this is where I said in my description of this talk that this is an inadvertent dependency injection framework, because I never actually thought of it this way. It just kind of came out this way, and it has enabled some very interesting behaviors. This is kind of off to the left or right side. So what I'm going to do here is nest some namespaces in. Instead of putting these things all in the root of my mapping, I'm going to put them in this sub-dictionary called storage. If I run my program right now that way, find that all of a sudden these have become dotted pairs in our commands. The storage.user invites the idea that we could have multiple storages, multiple different kinds of connections to resources or to Postgres. So let's do this little trick here. Again, we're going to write out an INI file. We're going to export storage double underbar user. Wait a minute, double underbar? Who knew? In the Unix shell, you can't have the dot in a variable name. There's no legitimate reason for that. In fact, some versions of BSD allow you to put the dot in. So I made Configman understand double underscore as I really mean dot. If you don't like that behavior, it's easy to change it in that list of value sources. So anyway, I'm going to set the user equal to Ethel. I'm going to say the database name is Fred, and I'm going to write out an INI file. Here it is. The INI file now has a section header called storage. If we use config object, we can have multiple nestings of those sections, and they'll just happen automatically. Dynamic loading, another level of indirection. Let's take those configuration parameters. Instead of putting them as literals in our program code, let's put them into a class and make a class level variable called required config. So then our default simply becomes our storage subsection, namespace actually, and a storage class and a reference to the class that I want to be the default. So essentially we have the single brick application here. There's only one application parameter. And if I run help, boom, we have a lot more than just one application parameter here. We have that storage class on the top, but when Configman saw that it was a class, it looked in it and said, is there any required configuration here I should know about? It saw there is. It brought them into the same namespace as the thing that it loaded from and loaded them all automatically. Now this gets really interesting. So this is what happened. The basic, the default, was capable of loading in all of those things. Let's, on the command line, override that and say, no, we don't want Postgres. We'll define a new database called moosebase. And instead of having all of these connection parameters, it's got host name, URL, authorization key, and swamp number. And then we run our application, and we say the storage class is going to be moosebase. Configman goes out, sees that the default is Postgres, but it's been overridden by moosebase. And if you, since it came in from the command line, it came in as a string. And if you had configured your initial defaults to specify Postgres as a string, Configman won't even bother loading the Postgres module first. It will only wait to see who wins on the column and then load that variable. So MoveSpace comes in. We override from the command line, and instead of bringing in those blue ones, it brings in these pink ones from MoveSpace. And so if I do help, I find all of a sudden we have our storage class, and we have the 4 MoveSpace things set up for us automatically. Again, if I write out a configuration file, it will show MoveSpace things. Let's make up the ante here. Here's another database called BothBase. It has 2 nested dictionaries in, primary and secondary. One of them is Postgres. The other one is MoveSpace. We specify this one, or I'm sorry, I've got highlights here to show those things. They both have storage class, Postgres and MoveSpace. Run this on the command line and put BothBase in. Run help. Help expands out. You can see our primary storage. Our secondary storage, clearly Postgres, it's Postgres things. Our secondary storage and MoveSpace things. Now, if our classes for Postgres and our classes for MoveSpace have the same API below hand, you can substitute easily MoveSpace with Postgres. And in this particular case, in fact, I have a use case where this was done where we had 2 of them. If the transaction fails in the primary, it falls back and tries the secondary. So you can just plug into a program that was only expecting one database to have a primary and a secondary. You're going to see a little bit later where this has been used to great extent at Mozilla in the crash reporting system. So here, another example where I'm going to use the BothBase. I'm going to get it by the environment this time. And I'm going to take that secondary storage and make it Postgres again. Run help. All of a sudden, MoveSpace is gone. Postgres is back. So we have 2 instances of Postgres, a primary and a secondary, or however you want to do it. So essentially, with Configman, classes can load classes, which can load classes, which can load classes, which might load some classes, and thereafter load more classes. What do we have? This is what we have. We can go as deep as we want and be as colorful as we want with this. So we've seen dynamic loading of classes. What about dynamic loading of modules? Now this is an interesting idea. What if we define Postgres like this, and we put the DB module, the DB API module, and set it to psychopg? So when we ran our program, instead of having psychopg hardwired into our code, we allow you to pick that up from configuration. So if for some reason we decide we don't want to use psychopg and want to use the old PyGresQL module, we can actually specify it on the command line and use it there. Or specify it as an application default. If the library said we're going to use psychopg, and you say, I don't want to use psychopg, you can change it at any time, anyway. All right, a little bit more control. We had started this out by using just a basic dictionary key value, string to string or string to integer stores. We can use a different language to define what our configuration parameters are. How many people are familiar with argparse? So with argparse, you get a parser argument and you do add argument, add argument, add argument. I have a very similar method here where we have namespaces, just like argparse namespaces, where you can make those nested things by simply saying namespace, the name of the namespace, and from then on you can access it via kind of a document model. I am from Mozilla after all, where you have dot, thing, dot, thing, dot, thing, dot, rather than using the square bracket, which I always hate so much because on my keyboard they're in a very strange location and they're hard to reach. So the option objects, same as the argument objects in argparse, give us several different things. We can name the storage class. We can put a document string in finally. We didn't have one earlier. We can put the default. Note I put it as a string here because I'm specifying a function here that will take whatever is the string version and turn it into what it's really supposed to be. That's the type. Same thing as type in argparse. These are the options that you can set. The options, which, by the way, if you're playing around with Configman, you can actually change those too with Configman. it gets a little overly recursive. They're just very simple. I'm not going to go through all of these things. This is not a tutorial. Aggregations. This is like post-processing. We can specify a whole bunch of options, and then Configman will build you this library or this key value storage of your configuration variables. Sometimes you might want to post-process those before you actually use them in your program. That's what aggregations are. You can add, in this particular one, I'm adding a connection key to my configuration, and it's going to be this database connection function. That connection function looks like this. It accepts two parameters, two mappings, and simply makes a DSN by taking the local config, putting it into a string, passing it into whatever the DB API module happens to be, whatever it's been set by the command line or environment or whatever, passes the DSN, gives you a connection object, and returns it. So then in your program, when you actually want a cursor object to talk to your thing, you get it from configuration. Configuration storage.connection, connection being the name of that aggregation. Aggregations can look at the total configuration, can do anything they want, return any type of value they want. They can even return another mapping, which Configman will then parse and look for more configuration information that might be inside that. I haven't talked much about the configuration object itself. That's this thing down here, which I just pressed the wrong button. Don't blow up. Thank you. So this little object down here, it is, what do you know, a mapping. If you don't like my configuration object, which I call a .dict, which is a document dot separated thing, there's a hook. And you can put any, let's say, mapping in there that you would like. And Configman will populate your mapping instead of, as long as you comply with collections.mapping, everybody's happy. So this gives an example of how the config object uses the, as we'd say in C++, we overloaded the dot operator. I don't know, what do we say in Python? Same thing? Yeah. Okay, good. Okay, great. We've got all this flexibility. What the heck do we do with it? I introduced to you Socorro. This is the crash reporting system run at Mozilla. It handles between 3 and 5 million crashes per day that we receive. And it looks like this. This is the layout of the internals of the crash reporting system. So we start with Firefox crashing. The crash report goes up to the collectors and gets shoved into a local file system. This is Apache running. Then from the local collectors in that file system, it gets moved out to HBase for permanent storage, and the ID gets sent into RabbitMQ, a queuing system. The processors then pull from the queue, get the queue of the idea of what to pull from HBase, and then they perform a miracle. They take that crash report, remarry it with the symbol tables from the build system at Mozilla, so that we can find out what actually was the state of Firefox when it crashed. We save a copy to HBase, another copy to Postgres, and another copy to Elasticsearch. So we're saving the same thing in 3 different places. Have we seen an example in the last 10 minutes about a database system that could do that? Every application in that thing is based on a 3-part design. Now, I apologize, I'm overloading Legos at the moment. These no longer mean configuration information. These are software components. So fetch, transform, and save. Every one of those applications is going to fetch data from somewhere, transform it in some way, and save it somewhere. We can generalize that to this. A fetch, transform, save app has required configuration of a fetch storage class, a transformation class, a save storage class, and some sort of producer-consumer system. For the collector, fetch is a web connection. The collector itself is a WSGI app. The file system is out storage. So we have classes. Those aren't actually the class names. That's more pseudocode than anything. So at configuration time, we set a fetch, transform, save app to these things. It's Apache web server. We give it to mod WSGI, and it collects our crashes. The crash mover, the thing that moves things from temporary file systems into HBase and RabbitMQ. It is fetch, transform, save. The file system is the source. The transform is null. It's not changing these things in any way. It's pushing them into HBase and Rabbit, and it is a multi-threaded producer-consumer class. Now, multi-threaded often upsets Python programmers. I personally embrace it. I really like multi-threaded programming. But if you don't like it, it's a Configman parameter here. You can plug in your cooperative multitasking. And I have created one based on greenlets. Or a single thread system. Whatever you wish. The processor reads from HBase and RabbitMQ, and its processor, or the transformation algorithm is called the Hybrid Processor Algorithm 2012. It uses the breakpad stackwalk programmer. The save storage class does HBase, Elasticsearch, and Postgres in the same way as that earlier example. The producer consumer class is multi-threaded, and it uses RabbitMQ as the source of its product. The middleware, it's just like the collector, except it's just a web interface to get data out of the system. We use it internally. Internal apps will query the Socorro system to get information via the RESTful interface, and it reads from any of those data sources at the bottom. Again, Apache web server is the thing. So Socorro is a collection of cooperating classes with a very well-defined set of business logic APIs. So it's loosely glued together with frameworks based on Configman. Right now, we are storing to HBase, Elasticsearch, Postgres, and RabbitMQ. We have our relationship with soured on HBase and Hadoop. We are moving everything to Ceph. How much re-engineering to this system do we have to do? All we have to do is re-implement for Ceph this business logic API and say what our Ceph connection parameters are, and just hand it to Configman, and it will just integrate into the system seamlessly. This has actually worked. This is how we got HBase in the first place. So, what are the benefits of using Configman? Agility. New components can be developed and deployed very rapidly. The Ceph module, 2 days of engineering time, and it was production ready, essentially. Continuous deployment. We're moving to a system where we're doing DevOps and doing continuous deployment. It is dead simple to feature flag using this system. You can either just install in classes or just add a configuration parameter that turns something on and off. We have a binary. And it integrates into the IT culture that you may encounter, because it's going to use whatever key value storage is locally fashionable. Downsides of Configman. The complexity of the interconnections in the code get moved out of the code and into configuration. This causes a potential combinatorial explosion in the number of ways you can put things together, which makes integration testing critical. It also takes time to understand Configman. Almost all the engineers, except me, look at it and their heads start to roll over to their side and they don't understand what's going on. And the biggest problem here is that it was written by an old insane man that hates writing documentation and rails against coding style standards. The Configman, the reason I said at the beginning you're not likely to use this is because our configuration is rock solid. if you consider pumice to be a rock. And as the coding style standards, I may rail against them, but the whole thing is pretty much PEP 8. Unfortunately for me, in living in the Python world, PEP 8 gives all code for me a bluish cast. I don't know what it is, but it does, and it's rather distressing to me. So if you want to try Configman, you can get the conservative version that is currently in use in Socorro at Mozilla by just saying sudo pip install configman. It's the production release. If you want the fun stuff, you have to pull it from my GitHub repo on the bleeding edge branch. I'm going to give you a link here. You don't have to try and memorize all of that. I'm going to give you a link to this presentation that is easy to remember. So questions and comments? Do you have any? Yes?
You said you were moving from HBase to Ceph.
Yes.
First off, what is Ceph and why did you choose to do that?
I was not involved in the decision-making process. Ceph is another massively distributed storage. And it's cheaper for us than HBase has been. That's all I can say. Yes?
How much work would it be to incorporate checking for the existence of empty flag files? Like I've worked at places where the sysadmins will say, oh, give me a file that I can create. If that file exists, that means yada, yada, yada.
So the question is, what support, I'm going to have to
using empty flag
use
files
empty flag files.
to modify your system. So instead of adding like an environmental variable, you say, if this file exists, that means it's in
Okay.
safe mode.
So what you would do to do that is create using the namespace.option. You'd create an option which would be a value of true or false, Boolean. And in that from string converter function, you would just make something that goes out to wherever your file system is, which would probably be another variable saying where the root of your file system is, and go out and look for the existence of the file, return true if it's there, return false if it isn't. So, any other questions? Yes?
So I'm already using argparse for a pretty complicated command line program.
Mm-hmm.
Lots of subparsers.
Right.
But I'd like to have a good way to get all my shared settings
Mm-hmm.
loaded from the environment. Exactly
Right.
what you're talking about. Is this, do I replace argparse with this, or does it work with argparse?
There are a couple different ways you can do this. On my blog, I have an example, a blog posting called Crouching Argparse Hidden Configman. And in that particular branch, which is on my bleeding edge branch, instead of importing from argparse, import parser. From configman, import parser. And you will get an argparse parser. It is argparse. It isn't configman, it is argparse. But by getting it from configman, configman is going to take your configuration, put it into configman, and fake out argparse to think it is the final arbiter of what the value should be. It will be invisible to your program except for the import line. You will use argparse exactly as you used it before, but you're going to find it will all of a sudden have all of these admin options for writing out config files and that sort of thing. You can also, if you have an extensive library of things that you have defined in your data definition language for argparse, you can just give your instance of your parser as a definition source to configman. And it will go in and tear apart your argparse parser, find out what all your variables are, create configman versions of those variables, and then turn around and use your instance of argparse to read from the command line. And fake out argparse enough that if you have any classes in there, that it will understand the whole recursive descent and dynamic loading of classes. More questions?
This was the best use of color I've seen in a presentation. Yes.
That is not a question.
Comments.
Oh, comment. I'm sorry. Hoisted. Here, let's see if. Let's just get rid of that.
Presentation that use better use of color.
I don't know. I don't go to presentations.
Oh, that's good. Entirely in Firefox. So this is you in the text editor writing out this?
Basically, I used the Wing IDE to edit an HTML file.
Go Wing. And that's the source? Oh,
This is where you'll find my presentation. Uncommonrose.com. I used to run a nursery, an online nursery specializing in rose bushes years ago, called the Uncommon Rose. I've kept the domain, and I use it for just anything. The actual framework for the presentation is a system called Slides, written by somebody named Brian. Yes, Brian something. I usually have the slide at the end that says his name, but I don't see it here this time. So I blog on twobraids.com. My Twitter at twobraids, the digit 2. And my email is lars@mozilla. And that's my presentation, Configman. Thank you very much for your time.